Today we're going to be looking at ratios. So ratios compare two numbers by division. And we've got a few different ways we can write a ratio. First one is A to B with the word 2 in between, A to B with a colon in between, or A to B as a fraction, so long as B does not equal 0, because remember in this class, division by 0 is undefined. And that last one, the fraction, is the one that we are going to focus on. So remember that slope is a ratio. Remember that slope is rise over run, or y2 minus y1 over x2 minus x1. So in general today you're going to have graphs, so I do recommend using the rise over the run, and always going up or down first and then to the right. So up or down first and then to the right. And we're looking for the slope of line M. Line M is this line. And so we're going to go up 1, 2, 3, 4. So that's a positive 4. And over 1, 2, 3, 4. Another positive 4. So we have 4 over 4 for the slope of line M. And 4 over 4 reduces to 1. Make sure you are reducing your fractions today. Next up, the ratio of the angle measures in a triangle is 1 to 6 to 13. What is the measure of the smallest angle? So remember that we are dealing with a triangle, and that we're dealing with the angle measures in a triangle. And all of the angles in a triangle added together always equal 180 degrees. So this would be like if we had a triangle, we had 1x, 6x, and 13x relating the different angle measures. So that's what we would add. 1x plus 6x plus 13x equals 180. We combine our like terms, and we get 20x. Okay, and then divide both sides by 20. So x equals 9. And we are interested in the smallest angle on this one. And our smallest number over here would be 1. So we would have 1 times 9, which is 9 degrees for our smallest angle. Next up, cross product or cross multiplication. Cross multiply. You take two ratios, so A over B and C over D. And when you set up two ratios and they're equal to each other, it is called a proportion. And make sure B and D aren't 0 because they're in the denominator and we don't divide by 0. And then we are going to cross multiply. A times B equals B times C. Now some of you will remember this as the butterfly method. Multiply those two and you are multiplying these two. So that's what we're going to do on our next problem. 5 times 63 equals 45 times y. And 5 times 63 is 315. So 315 equals 45 y, and then we're going to divide by 45 on both sides. We're going to do the same thing on the next two problems, cross multiplying. So 2 times b equals 3 times 6. And 2 times d equals 18. Divide by 2 on both sides, and d equals 9. And same thing on the next one, cross multiplying. So 2 times 4y equals 9 times 8. 2 times 4y is 8y equals 72. Divide by 8 on both sides, and y equals 9. Next up, during the filming of The Lord of the Rings, the special effects team built a model of Sauron's tower with a height of 8 meters and a width of 6 meters. If the width of the full-size tower is 996 meters, what is the height? So I am going to draw a couple of figures over here. We've got towers, and our model is 8 meters tall and 6 meters wide. Our full-size tower is 996 meters wide, and we're looking for the height. Okay, so I'm going to set up our proportion just like we see here. 996 is our width over what we're looking for, our height, because it goes with the 996. Those are both the full-size measures. Then we started with our width over our height, and we have the full size on the left, which means we have the model on the right. So we need the model's width, which is 6, over the model's height, which is 8. And then we can cross multiply. 996 times 8 equals 6x. And 996 times 8 is 7,968 equals 6x. Then we're going to divide by 6 on both sides. And once we divide by 6, that means that x is 1,328 meters. Okay, then we have similar polygons. So two polygons have congruent corresponding parts, and two polygons' angles should be are similar, and our symbol for similar, remember, is a squiggly line. When their corresponding angles are congruent and their corresponding sides are proportional. So we need to double check which angles are congruent, and angle A is congruent with angle E. Angle B is congruent with angle F. Angle C is congruent with angle G. And angle D is congruent to angle H. So the angles have to be congruent, and then the sides have to be proportional. So if you take 6 over 12, 5.4 over 10.8, 4 over 6, or 4 over 8, sorry, and 5 over 10. Do all of those reduce down to? They all reduce to 1/2. So our similarity ratio for polygon ABCD to polygon EFGH is 1/2. Now, when we are going the other direction, from our larger polygon to our smaller polygon, those numbers flip places. So we'd have 12 over 6, 10.8 over 5.4, 8 over 4, 10 over 5, which means that our similarity ratio for polygon EFGH to polygon ABCD is 2. And just like we had congruence statements with triangles, we have similarity statements with polygons. And polygon ABCD is similar to, notice that's just the squiggle, not the congruent sign, is similar to polygon EFGH. Notice that these letters are capitalized. Here should be 2. Also remember that when you're naming your similarity statement, just like with your congruent statements, your congruent angles need to be in the same order. Next up, we want to determine whether the polygons are similar. Then identify the corresponding angles are congruent and corresponding sides are proportional. If they are, we want to write a similarity ratio and a similarity statement. So the first one, we have 2 rectangles. And what do we know about the rectangles, the angles in all of the rectangles? They are 90 degrees. So I'm not going to list out which angles are congruent to which other angles. I'm just going to write that all of our angles are congruent because they're all right angles. Then we need to look and see if our sides are proportional to each other. So 4 matches up with 6. 12 matches up with 16. Are these equal? So what does 4, 6 reduce to? It reduces to 2/3. And what does 12 16 reduce to? 3/4. Okay, so are these equal? No, they're not equal. And because they're not equal, that means that these polygons are not similar. Next up, we are looking at 2 triangles. So we need to look and see which angles are congruent. So we have angle A with 1 arc mark and angle D with 1 arc mark. So angle A is congruent to angle D. And we have angle B with 2 arc marks and angle E with 2 arc marks. So angle B is congruent to angle E. And then we have angle C and angle F. They have no arc marks. But we already have 2 sets of angles in our 2 triangles congruent. So we know, because of the third angle theorem, that the last set of angles are congruent. That means that angle C is congruent to angle F. Now notice that I labeled my congruent angles in order. I kept one triangle on one side and the other triangle on another side. This will help me with my similarity statement later if these triangles are proportional. So next up, I need to check that these sides are proportional. So I'm going to start with 16. 16 is my smallest side, and over here my smallest side is 12. Notice that it's also between this angle that is marked with 1 arc mark and the one that's marked with no arc mark. And that's the same on this first triangle. So we've got 16 over 12. Then we have 20, which is between the angles with arc marks, which means we've got 15 that matches up with it. And that leaves us with 24 over 18. Now notice, every time my left triangle was on top, my right triangle was on bottom. You could flip them, but you have to flip all of them to be able to check for proportionality. Okay, and what does 16 over 12 reduce to? 4/3. And what does 20 over 15 reduce to? Also 4/3. And what does 24 over 18 reduce to? Also 4/3. Now these all reduce to the same thing, so this is our similarity ratio. And that means that these triangles are similar, and we need to write our triangle congruent statement. So that means that triangle ABC is similar to triangle DEF. Now if you're looking for this symbol on a computer, it is typically up in the upper left-hand corner of your keyboard. Now notice that I wrote out triangle once and did the symbol for triangle the other time. If you are on a computer, you need to type out the word triangle. If you are in class writing this on paper, you can use the symbol. Next up, we want to find the length of the model to the nearest tenth of a centimeter. So we need to set up a proportion, because that's what we've been dealing with today. So we have 5 over x, because those are both the lengths of the car, equals 1.8 over 6.3, because those are both the widths of the car. And then we're going to cross multiply 6.3 times 5 equals 1.8 times x. And 6.3 times 5 is 31.5. And then we need to divide by 1.8 on both sides. And that gives us 17.5 centimeters. Now, I know some of you are going, but my units aren't the same. On this, it doesn't matter that you don't have to convert, because your units actually cancel out with this, because we have meters getting divided out when we multiply. You can convert, but you don't have to.